Hello, I'm Dr. John Kruse, and today I'm going to be talking about intermittent fasting and whether it's any good for you or not. So, as usual, I'll start with the take-home message. There has been a huge surge in interest in intermittent fasting over the last few years, with claims that it will help you lose weight, help you be faster, smarter, stronger, stop aging, a whole host of other issues. And in summary, what the data suggests, one is we have much more solid data in animals, particularly rodents, than in humans. And the human data is equivocal, and I would rate it as certainly not as impressive as the proponents are cheering it on for, and also not nearly as trivial or inconclusive or unsuggestive as the critics are dismissing it as. So let's launch into what is intermittent fasting. It doesn't have a precise definition, but it pertains to intentionally depriving yourself of food for certain parts of the day or certain days of the week. And usually it's lumped into three big categories. One is called time-restricted eating, where during the 24-hour clock, someone is only eating a certain portion of the clock. And usually you're only eating 8 hours, or you're only allowed to eat during a window of 8 hours and not for 16, but it could be limited to just 6 hours. Muslims who are celebrating Ramadan there's a number of studies looking at them, because if you're only allowed to eat from after sundown and most people are going to bed several hours later, that's a form of time-restricted eating that's usually less than 6 hours, probably in the range of just 4 hours. So that's one type of intermittent fasting. Another category is alternate day fasting, where you eat what you wish one day and you eat nothing, or in some conceptions, a very reduced amount of food in an alternate day, and usually reduced for studies is defined as less than a quarter of your normal caloric intake. So you're alternating days of eating what you want, and then the next day either eating no food or substantially less than it would be sustainable for you. And then a third category is called periodic fasting, where similar to the alternate day, but it's not every other day. You are on some schedule where some days you eat at normal times and as much as you're comfortable eating, and other days you are fasting. And again, the fasting is usually defined as no food up to about a quarter of your daily caloric supplements. And popular schedules of that would be a 5-2 schedule, where 2 days every week you may be fasting, and for some people it would be the same 2 every week, others would vary it, or a certain number of days a month where you are fasting and allowing yourself to eat the other days. So why in the world would affecting the timing of eating have any big impact on the body? And we have at least 7 different reasons and approaches, and I'll start with the simplest one. And again, the biggest number of studies in the area this has been studied most at is simply body weight, particularly given that so many, not just Americans, but individuals worldwide are struggling with carrying more weight than is probably healthy, and for most of them is than they desire to be carrying. So one of the simplest explanations is maybe if you're just restricting the timing, you're getting less calories, you're eating less overall. And certainly some people who are restricting timing or intermittent fasting are consuming fewer calories. Certainly you can devise diets where you are not doing any calorie restriction, and you can specifically just study the timing of fasting, or timing of eating. But this is a potential confounding variable in terms of you get good results if someone's lost weight or is smarter or X, Y, or Z. Is it just a caloric restriction issue, or is it really doing a result of the timing of eating? Second explanation would be that people might just be eating more mindfully and eating better, not just, so if you're telling people you can't eat until 10 in the morning and you're going to have to stop eating at 6 at night, then most people are forced to think more consciously about what they're putting in their body. And particularly if they're in a study, they also may be more focused on what they're eating and trying to eat more healthily. And again, the quality of their nutrition may differ, again, separate from whether it's truly so the results may be attributable to a better selection of food, not just a timing of the food. Third level of explanation, and this topic's big enough, I will be talking about it next month because there is a fair amount of study in the mental health research, and that is sort of the ketosis hypothesis. So under most humans' eating conditions, particularly in Western countries, we are utilizing glucose as our major energy product. So some of that glucose is from food we're directly consuming, or fructose, simple sugars that are broken down into glucose. And our liver also stores glycogen. So it's a bunch of glucoses strung together. And during most of the time, most days and nights, we are breaking down liver glycogen to get the glucose that fuels all the cells in our body. However, if you fast long enough, and the long enough depends on a lot of factors. One is how much glycogen is stored in your liver. Two is how physically active you've been. There's a few other factors that can contribute. Then your body undergoes what's called a metabolic switch. And once your glucose supplies are exhausted, you start burning ketones, which essentially come from fat in your body. So it's a fat burning approach. And this clearly could well have implications for not just weight gain or loss, but also a whole host of other functions in the body. So whether intermittent fasting is due, or how much of the effect is due from inducing a state of ketosis or not, is one topic open to question. Again, I'm going to talk about ketosis in a later time, so I'm just mentioning it there as a possibility. Number 4 possible explanation for how intermittent fasting could be working is tied in with circadian rhythm effects. So we know most people are familiar with that we have a clock in our head that sets a whole host of biological functions. So the most familiar one is when you're likely to go to sleep, when you're likely to wake up. But our circadian clock isn't just tied into sleep or pertinent to sleep. It's almost every physiologic variable, from body temperature to release of different hormones to blood pressure to more complicated behavior, how quickly you can add up in numbers, has an innate rhythm set by different biochemical rhythms in your body. And the thought is, if you're sort of eating across the time spectrum, across the circadian day, you are muting, you are muffling, you are flattening out some of these curves. But if you sharpen up or tighten or restrict the amount of time you're eating to the daytime specifically, which is probably evolutionarily when humans were eating and body systems were designed to be ready for dissolving or digesting foods and energizing the body, any way that you may be strengthening circadian rhythm systems. This is particularly pertinent to some mental health issues, because we know not just bipolar disorder, which has rhythmic factors, but with depression, most people who are depressed show actually rhythms during the day, the commonest pattern being most depressed or sad when you wake up and having some improvement in mood during the course of the day. That's also a common anxiety pattern, but it's not the only one. But even ADD, I mean, we know that the majority of people with ADD are night owls. That's under biological genetic control. Not that you can't try to adjust it or lap with it. And there have been a tiny number of studies using the same bright white lights that are used for treating seasonal affective disorder to shift circadian clocks of individuals with ADHD and no depression, and found measurable cognitive improvements in a range of ADD measures just from bright light morning treatment. So intermittent fasting may be having some of the effects just through circadian rhythm, circadian clock strengthening or altering mechanisms. Another possible source of how it might work is altering the gut microbiome. So if you're feeding your gut over, again, much of the day, you favor the growth of certain types of bacteria. If you restrict eating to narrower window, different types of bacteria are proliferating. And we know that the gut microbiome does have some ability to change neurochemical balance in the body and to change brains and behavior. Separate from just the gut microbiome or tied into it, there's something called the migrating motor complex. So there are about every hour and a half pulsatile movements of muscle contractions through the digestive system, which, I mean, there are steady peristalsis-like movements, and there are movements of the muscle system triggered by the presence of food, but these are, again, an inner clock seems to be driving things. But if you're eating, again, through much of the waking day, this migratory motor complex doesn't work as it would design if you are spending larger amounts of your time fasting. And that migratory motor complex does redistribute the microbiome. It shifts where the highest concentrations of bacteria are. So it's pushing them further down the colon. And again, that may be a reason both for weight, metabolic, and maybe even behavioral changes that intermittent fasting could create. One other, or two others, so inflammation. So intermittent fasting seems to be associated with lower inflammatory states. Probably a number of different chemical pathways are involved, but inflammatory states are implicated not, again, just with weight gain and aging, but also with a host of mental health issues, with probably depression and schizophrenia the most well studied there. And then number 7, one of the other chemical systems that's triggered or boosted by intermittent fasting and by exercise is what's called the sirtuin system. So these are a group of enzymes in the body. And David Sinclair, who's a Harvard aging expert, and so his theories, and there's a good deal of laboratory support for that, is that aging is tied into not the degradation of our genome, our DNA systems in each cell, but of the epigenome. So the epigenome, so each cell has the same DNA in it in a human body. But what makes a liver cell, and a skin cell, and a brain cell have to do with which genes are turned off and which are turned on, and the turning off and turning on of different cells, which is not just specific for the type of cell, but also varies through the course of the day and seasons of the year and several other factors. Is so that the molecules, the acetyl groups, the methyl groups that are stuck onto the DNA to either activate or inactivate it are called the epigenome. And we know that intermittent fasting in animals and exercise are natural ways to boost the activity of enzymes that are called sirtuins. The sirtuins are involved in affixing or not affixing acetyl groups to the epigenome. So they are activating, they are monitoring, they're keeping the epigenome the way you would want it be for each individual cell. And there's fairly extensive laboratory animal, particularly rodent data, showing that administering extra doses of some of these sirtuins do seem to reverse many signs of aging in many organ systems, including some signs of reducing brain aging. So intermittent fasting may be mediating some of its effects through sirtuins and through our system that helps reverse or prevent some of the ravages of aging. So again, those are some of the common mechanisms that are proposed. All of them may be involved. Some of them may be more important in different individuals. Again, the overall data is less than solid and convincing. Part of it, particularly aging studies on human, it's hard to see. You have to wait a long, long time to see if intermittent fasting is having an impact on longevity. So I'm just going to pick on two different studies that were done recently and got a fair amount of media attention. One is a study, touting intermittent fasting is great. It was looking at cyclists, and interestingly, it looked at middle-aged men, so not just college-age youth, which are often people who are studied. So these middle-aged men were cyclists to begin with. They were put on a 4-week, 16-8 restricted feeding schedule. So they're only allowed to eat 8 hours during the waking day. And at the end of just 4 weeks of this treatment, they had measurable and statistically significant decreases in body weight. And that was specifically a decrease in body fat. So lean muscle mass did not seem to change. Statistically significant decrease in blood pressure, and significantly statistically and not just trivial, an 8% difference and increase in the speed with which they did a time trial study. 8% improvement in a month for anyone who's already in reasonably good shape is a pretty remarkable achievement. This paper was picked up by a lot of exercise and not just cyclists, and touted as this can help runners and anyone else who's doing athletic exercise. And there are other studies looking at that seem to show benefit. But if you look at this study more closely, they had 12 people in the study, just 12. Yes, the results were statistically significant, great, but how replicable this is, how relevant this is to others, and much more important, people served as their own control group. So they were compared to where they were at baseline. That sounds like a reasonable approach. But without a control group, how do you know it wasn't just being told, oh, you're in this great study that's going to see how much we can improve your performance by. So with the lack of a control group, really, in my mind, weakens. It doesn't disprove it. It doesn't mean this isn't real and genuine, and most people would see that type of improvement who switched from a eating whenever you want to a 16-8 restricted timing eating diet. But it's a pretty tiny and pretty weak study. So on the other hand, another study that got a fair amount of attention, I think it was published in November, was a study that looked at 1,000 people, and it looked over the course of 6 years for the trajectory of their weight, and then spent 6 months monitoring when they slept and when they ate each meal, and whether the meal was a small meal, big meal, or little meal, and then tried to see if there were correlations either with restriction of eating, when they were eating, versus the size of their meals or other factors in terms of what was correlated with any weight loss or weight gain over the study period. And their conclusion when they crunched the data was that they didn't see any sizable impact on weight loss from intermittent fasting, but they did see if you had fewer large meals, you were likely to lose weight. I mean, that itself doesn't sound surprising. And this, not just the article itself, but this was touted in other medical journals I've seen saying, well, this shows restricted eating isn't so important. We should just be telling people to regulate the number of large meals they're eating, and that's the key to losing weight. So problems with this study is, one is of more than 1,000 people enrolled in the beginning, almost half of them dropped out because they didn't want to, or they didn't continue to monitor their timing of eating, feeding, sleeping. So that is a pretty huge dropout rate. 2 is a measure. They took an average after they crunched the 6 months of data on eating patterns. For each person, they just came up with an average number. The average number was how many hours was it from the first meal to the last number? That's your eating duration during the day. What was the average time between wake up time and first meal? What was the average time between last meal and bedtime when they fell asleep? And in doing that, you lose a huge amount of data, particularly someone who's fasting every other day. And I mean, you wind up with a composite average measure of all of what's really happening in their lives, when there could have been more precise statistical ways of looking, someone who's eating over a 16-hour window one day and an 8-hour another would, in their study, look exactly like someone who is always, every day, eating over a 12-hour period. That does not give you the ability to discern whether intermittent fasting, whether specifically time-restricted eating schedule is helping any of these people or not. So the other thing I found interesting in the study, again, they were looking at weight loss over time. But if you look at just the statistics and what comes out most robustly is just looking at sort of the body mass index of the people again. So some of these people started out larger, some of them ended large, not changed during the time, but just how large these people were. There were very strong statistical correlations between how many hours a day people were eating. So people with the narrow window of eating had lower body mass index, and it was highly statistically significant. And people who were, there was also a statistical correlation, strong one, between duration of time between last meal of the day and bedtime. So the longer that gap was, the less likely someone was to be overweight. Now, maybe people who were larger, I mean, you can't tell causality from that. You can't tell whether eating patterns changed weight or whether weight changed eating patterns. But it was interesting because the article and the interpretation in medical journals has been so dismissive of the intermittent fasting as a way of possible losing weight. And I would say that there's a massive evidence in favor of it in that very article. So that's about all I know. This might have felt a little off topic for direct ADHD or mental health, but clearly there's much more study going on. Again, there's encouraging data that this can change aging processes, and I think we will increasingly see intermittent fasting studies being applied to mental health. And again, I will be talking about ketogenesis and keto diets specifically sometime in March. So I am not seeing any questions related to today's topic or anything else. I'll stall for a moment or two to see if anyone wants to type anything in. Next week's topic is going to be borderline personality disorder and ADHD, and there is a considerable overlap and potential for confusion there, which many clinicians aren't aware of. So I'm seeing so Dennis has a question that is quite pertinent. It says, so I should backtrack a little bit. And his question, part of why I jumped into this question is one of the things I often tell people when I'm doing an intake evaluation or in the first few sessions, if they come in and remark, wow, yesterday I was at work and it wasn't until 4 o'clock that I realized I hadn't eaten lunch all day or I hadn't eaten a meal all day. Almost always to me that's a flag for considering ADHD. Now this is different. Again, some people may consciously restrict their meal times, consciously avoid eating, but most people don't just forget to eat, but it's not uncommon in ADHD. Some of it, again, is the just being less attentive, but I think there's a strong correlation with less attentiveness, particularly to interoceptive measures, signals from your body, and or greater distraction by what's going on. So Dennis asks, my psychiatrist said that skipping meal. So back to that. So usually I would encourage people to, if you're going to be functioning, your brain needs to be nourished. If you're already feeling hungry, you're behind the 8 ball. You shouldn't be eating because you're hungry. You should be eating to avoid hunger and to maximize the condition your brain is in. The intermittent fasting day, research suggests maybe I should just be content in letting my people with ADD who forget meals skip meals, because there may be actual benefits to skipping meals. So my psychiatrist said skipping meals can reduce the performance of ADHD medication stimulants and cause them to wear off faster. Could you explain why this happens? So there's a limited amount of data on absorption rates of some of the Adderall, amphetamine particularly. So the acidity of the gastrointestinal tract does affect absorption. So it may affect to some extent how quickly or the total amount absorbed. I don't know of any data that shows, I don't know of any at all, that there might be out there, but that shows that skipping meals reduces the performance of ADHD medications and causes them to wear off faster. My thought would be that if you're already in a state or on a given day, given that you're not forgetting your meals every day, that there may be higher demands on the day, that you may be more distracted, that you may be putting more energy and effort into concentrating, so that you effectively would probably have needed a bigger dose on those days. That's the best I can come up with. I also haven't addressed the topic that stimulant medicines themselves can affect appetite, and that can affect eating patterns, which I should have addressed earlier. So I hope that was an adequate answer for Dennis. But again, I'm not aware of specific data. Again, clinically, when I've seen it more not as direct eating causing medication changes, but more changes in eating patterns reflecting the mental state that that person was in each day. And we know that ADHD symptoms do fluctuate a lot from day to day, even on people medicated or not medicated. So that's it for today. Have a healthy, happy week and stay safe in this certainly at times dangerous world. Bye.